So today we will study about the force, right? So first I will define force. What is force? So force is that physical quantity which changes either the size or shape or a state of rest or motion of the body. Okay, I will explain one by one everything. Size, right? Size means suppose there is a box. I want to increase its length. So I pull this part, right, by some force. So its length will be increased from L1 to the L2 and size will come to this. So by applying force, you can change the size also, and we can also change the shape. Suppose original shape of any object is a square. So we want to change its shape into circular path. So by applying force from all the sides, okay, so we can change into circular path, circular shape, right? And for rest, suppose any object keeping on the rest position by applying force, it will be converted into motion, right? So force can change the shape, size, state of rest or motion of the body. So this is the definition of the force. So next point is force having magnitude and direction, right? Suppose I am applying force on this object, so it is having some numerical value like 10 Newton, and we are applying this force on this direction, right hand side. So it is having both magnitude and direction, right? And force is discovered by the Newton scientist. So in honor of that him, we give the unit N. Capital N is the unit of force, right? It is SI unit and CGS unit is dyne. So and if you want to convert in simple, so if formula is mass into acceleration. So mass unit is kg and acceleration unit is meter per second square. So this is the another unit of force. So right up to this point. Now look at the types of force. So there are two types of force. One is contact force and another is non-contact force. Right. So contact force, the force acting between two objects making a physical contact are termed as contact force. Right. So contact force name itself suggests that when two bodies are in contact and force is applied between them, that is called contact force, right? Like frictional force. Suppose any object is lying on the surface and we are applying the force. So this force is contact force. Another one is normal reaction force. Suppose there is table in which an object is kept. So this table is applying normal force to this object upward. So that is represented by capital N. Capital N represents for normal reaction force. Next one is tension force applied through a string. Like suppose this is a string and it is tied with another and rope is passing over it and another object is hanging on other side. So the force developed on this string is called tension force. So tension force applied through the string. Next is muscular force. Suppose one man is pushing the another man with a force. That force will be called contact force with the muscular force also. Okay. Next one is force exerted during collision. It means suppose an object is there and you are striking that object with some velocity v. So that type of force is also called contact force and it is called collision. So you will study in another class types of collision: elastic collision, perfectly elastic collision. Okay. So there are three types of collision you will study. Next type is non-contact force. The force experienced by two objects even without being physically attached. That is called non-contact force. So in non-contact force, example is gravitational force, right? Suppose this is our earth in which we are living on the earth surface. So force developed between mass of the earth and myself is called gravitational force. So its formula is F equal to G capital M small m upon R square. So R is the radius, capital M is the mass of the earth, and M is the mass of mine. Okay, and it is represented by F, and G is the gravitational constant. That is the example of non-contact force. Next one is electrostatic force. So electrostatic force is that suppose there is two charges Q1 and Q2 and distance between them is R. So there is force developed between them. So it will be F equal to K Q1 Q2 upon R square. So this is called electrostatic force, right? Next one is magnetic force. Magnetic force, I will explain. Suppose there is an wire in which current is flowing. Okay, from bottom to top, current is flowing. So right hand thumb rule states that when we are holding the wire, this thumb gives the direction and this curved finger will give the magnetic force around it. So that is called magnetic force. Okay, so these are the types of non-contact force. Right up to this definition of contact force and example of that. Next topic is Newton's first law of motion, right? So according to Newton's first law, if a body is in state of rest, it will remain in the rest or uniform motion, okay, until and unless an external unbalanced force is applied on it, okay. Suppose an object is at rest, suppose it is not moving, so unless external force is applied on it, then only it will change its position from one to the second, right? That is called Newton's first law. Or suppose an object is moving with velocity u. This is the uniform velocity moving the constant velocity, suppose 40 km per hour. If you want to change its velocity, you have to apply the external force. That is called Newton's law, first law of motion, right? Its example is a book lying on tabletop will remain in its place unless some force displaces it. Okay. Suppose there is book lying on the table, it will remain rest at the table unless and until we are not applying any force or we are not taking from that position to another position. Okay. Next example is a ball rolling on horizontal plane keep on rolling unless force of friction between ball and plane stops it. Okay. Suppose we are rolling a ball, force of friction. So without friction, if there is no friction, it will keep on rotating. If you are applying any friction, external force, then only it will stop rolling. That is called Newton's law of motion, Newton's first law of motion. Okay. Now next topic is Newton's first law can be understood in the following two parts. So Newton's law of motion is also called inertia, right? So inertia means inherent property in an object by virtue of which it neither changes its states nor tend to change the state. It's called inertia. Suppose we are here, a book is lying. It will remain its at position, okay, unless an external force is applied on it. That is also called inertia. Next is definition of force. Force is called external cause that tends to change the state of rest or a state of uniform motion of an object. Okay. This is the definition of force. You must be knowing. Na? So what is the relation between mass and inertia? Every object possesses inertia due to its mass. Okay. Greater the mass of object, greater is its inertia of the object. Inertia is directly proportional to the mass. So this is the direct relation between mass and inertia. Greater the mass, inertia will be greater. So mass is the measure of inertia. So now look at the point. When we kick a football, it flies along, but the same time we kick a stone of the same size. It hardly moves as the stone resists a change in motion better than football cause of its more mass. ठीक है? Suppose they are looking at the same shape but mass having different. So stone having greater mass as compared to football. So we can't kick the stone because of its mass. So inertia is directly proportional to the mass. So here a stone having larger inertia as compared to football. So we cannot hit the stone. So this is the relation between mass and inertia. Write this one. Now look at the next example. Cricket ball is more massive than a tennis ball, right? Because cricket ball having greater mass as compared to tennis ball. In in case they are moving with the same velocity, it is more difficult to stop a cricket ball as compared to tennis ball because cricket ball having mass more as compared to tennis ball. ठीक है? So cricket ball having more inertia as compared to tennis ball. So now look at the different types of inertia. First one is inertia of rest. Second is inertia due to motion. So first is inertia of rest. Look at the type. First type, inertia of rest. If a body is at rest, it will remain at rest unless an external force is applied to change its position or state of rest. That is called inertia of rest, right? So earlier I have told you that suppose a book is lying on the table, it will not change its position, right? From it will not come down or it will move to your another table, right? Unless and until external force is applied on it. That is called inertia of rest, right? Now look at the example. First example, when a bus suddenly starts moving forward, passenger stands in the bus tends to move backward, right? The reason is that lower part of the passenger body is in close contact with the bus. As the bus starts moving, lower part of the body gets jerked forward. But at the same time, upper part of the body, due to inertia of rest, remain at the rest at the same place. Hence, the lower part of the move ahead, but the upper part is left behind. Consequently, the passenger tends to fall backward. ठीक है? Suppose I am sitting on the bus and suddenly bus starts moving forward. So I tense back now because lower part starts moving forward, but upper part is at the rest now. So it will tense back so that we fall backward. That is called inertia of motion. ठीक है? Or it is called when we are at the rest, it is called inertia of rest. So this is the example of that. So write this one.
Yes, I took the screenshot.
Now next example is on shaking the branches of tree, the fruits fall down, right? Suppose we want to get fruits, so we shake the branches of the tree. The reason is that when the branches of the tree is shaken, it gains motion, but the fruit, due to rest of inertia of rest, it remains in a state of rest. These ribs or weakly attached fruits get detached from the branch and falls down due to gravity. Okay? When we are shaking the branches of the tree, that time fruits of the tree is at rest, and due to inertia of rest, it fall down, right? That is the example of inertia of rest. Next is when a hanging carpet is beaten with a stick, the dust particle starts falling out of it, right? Suppose we want to remove the dust particles from the beaten carpet. So hang like this and beat with the stick. So dust particle is at the rest. After beating, it falls down, no? Due to inertia of rest and due to gravity also. Okay, that is another example. Next one is on striking the coin at the bottom of pile of the carom board, With the striker, coins at the bottom moves away, while the rest of the piles remain in contact due to inertia of rest, right? Suppose we are striking the coins with carom board. So one coin will move, right? Rest will remain at rest, na, due to inertia of rest, because they are not moving before and after, because they are not getting the external force, na. That's why another coins will remain at rest. Next one is when a smooth card placed over the mouth or tumbler, it is flicked sharply in the horizontal direction. Cards flip away, but coin kept over the cards fall into the tumbler. Okay, this one is also another example. So write this example. So next one is inertia of motion. A body in a state of motion continue to be in the state of motion with the same speed in the same direction in a straight line unless an external unbalanced force is applied on it to change the state. This property of an object is termed as the inertia of motion, right? So inertia of motion is very simple. Suppose an object is moving with uniform velocity, will remain in uniform velocity unless and unless external force is applied on it. Okay? That is also called Newton's first law. No? So its first example is when a running car stops suddenly, the passenger tends to lean forward. The reason is that in running car, whole body of the passenger in the state of motion. When the car stops suddenly, the lower part of the being contact with the car comes to the rest, but upper part remains in the motion of inertia, due to which we have moved length forward. ठीक है, ये तो बहुत very simple example ना. Next one is when a passenger jumps off a moving train, it falls down. ठीक है. This is the reason that his whole body is in the state of motion, but the running train, on jumping out of running train, his feet touches the ground, the lower part comes to rest, but upper part remain in the motion. That's why it's fall down. So now, suppose a train is running and we
Yes,
want
sir.
to get out of it. So when we are jumping from there, our lower part comes to the rest, but upper part is continuing the motion. That's why we fall down. So this is the example of inertia of motion. So write this one next, then I will explain next one. Next, third one is a cyclist riding along a level road doesn't come to rest immediately after he stops paddling. ठीक है? Suppose we are riding on a bicycle and moving with some velocity. Suppose we suddenly stop the cycle. Then, however, we fall forward because our parts on the moving position. That's why. Next point example is a ball thrown vertically upward by a person in a moving train come back to his hand. That is also the example of inertia of motion, because when we are throwing it upward with the same velocity, ball is also moving forward and upward. Okay. Next is law is our Newton's third law of motion. Okay. We have before this we have studied Newton's first law. Now this one is third law. So look at the third law of motion. It states that to every action there is always an equal and opposite a spontaneous reaction. Okay. Suppose this is mass 1 and this is mass 2. So they are moving in opposite direction. Okay. Before collision, it will look like this. And during collision, it will collide each other. So this will impart the same force on this object and this will impart the same force in the this direction. So they will be in opposite in direction. So this is moving in this direction and this one is this one. So you can see on the diagram also their direction is opposite. So every action there is equal and opposite reaction. That is called Newton's law of motion, third law of motion. Next one is properties of action reaction force. So action and reaction force never act on the same body, right? Because there are two bodies now. Suppose this is having force F1, this one is having force F2. They are acting in opposite direction. Okay, this will collide on this one and this will collide on this one. So they always act simultaneously on two different bodies. So there are two different body, one and two. So they are acting in opposite direction. So action reaction force are always be present in pair. So when two bodies are there, then only action and reaction what happens. Okay. So they are always in pairing. Next one is these two forces are equal in magnitude but opposite in direction, but they still do not cancel each other. The force do not act on the same body. Third point, look at the third point I will explain. These two forces are equal in magnitude but opposite in direction. So you can see F1 equal to F2, but they are opposite in direction, right? So still they don't cancel each other and do not act on the same body. So F1 is acting on the second body and F2 is acting on the first body, and their magnitude is same but direction is opposite. So this is the property of action reaction force. So read this one and write one, then I will give you the example. Now look at the example one. When an object is placed on the platform, right? This exerts a force equal to its weight. So suppose this is an object kept on this table. So its weight is acting downward and the normal reaction action force is acting upward. So this object is acting this amount of force in downward direction. So this platform is also acting same amount of force in the upward direction but opposite in direction. So platform acting downward direction and platform balance it by equal and opposite force called reaction force acting vertically upward. So this is your action and this is your reaction. So these both action and reaction happens in pair form and they are equal in magnitude but opposite in direction. This is the first example of Newton's third law. Next example is when a boatman wants to move the boat away from the shore. He pushes the shore with his action. The shore pushes the boatman along with the boat away from the shore. This is the equal and opposite reaction example. Okay. Now next example is when a shooter fires a bullet from a rifle. So force F is exerted on the bullet and guns appears equal and opposite reaction in opposite direction. That is called also recoil force. Okay. So when we are firing this bullet on forward, we get the same recoil force in the backward direction. Okay. That is called recoil force on the gun. This is accelerating force on the bullet. So this is the example of Newton's third law. Now look at the another example, rocket motion. In a rocket, fuel is burned inside the rocket, right? And the burnt gas at high pressure and high temperature are expelled out of the rocket through the nozzle. Thus, rocket exerts a force F action on the gas to expel them through the nozzle backward. Okay. The outgoing gas exerts an equal and opposite force on the rocket due to which it moves against the gravity in the upward direction. Okay. So exerting for acting in the downward direction and this rocket on the upward direction. Okay, fuel. So burnt gas at high pressure and high temperature expelled out. So that why this one move forward. Okay, and it can move upward due to against the gravity. So gravity is pulling down the and due to burning of the gas, burnt gas exert the pressure on this nozzle to move forward. So this is also the example of Newton's third law. Action is equal, opposite reaction is happening there. Look at the fifth example. When we apply a force, action, backward by the foot on the ground against the force of friction, the ground exert an equal and opposite force, that is called reaction force, forward on the foot, thus enabling us to walk forward. So when we are putting the foot on the ground, so that is called action. So this is in this direction action is happening, and this ground pull with the same force so that we can move forward. So this is the example of Newton's third law. Action and equal opposite force is happening here. So this is also Newton's third law. ठीक है, ये आप लिख लो.